So think about this for a second. If you want to upgrade your car's engine, you have to pull over.
Right, yeah. You definitely have to pull over.
Yeah, you pull over, you pop the hood, and you turn the car off first. It's a fundamental rule of mechanics.
Absolutely.
You don't just swap out the spark plugs while you're flying down the highway at like 70 miles an hour.
No, because a combustion engine is tightly coupled.
Right.
All of its components rely on, continuous synchronized functioning.
Mm-hmm.
So if you remove a critical piece, even for a fraction of a second while the engine is firing, the timing shatters.
Yeah, the pistons misfire, the whole thing just goes.
Exactly. The whole system catastrophically fails.
But what if that car is an artificial superintelligence?
Right. That's the real question.
Because we're talking about a system that is so unimaginably complex, right?
Yeah.
And deeply integrated into, well, our global infrastructure.
Power grids, financial markets, logistics.
Exactly. It simply cannot ever be turned off.
Hmm.
So how do you swap the parts?
It's wild to think about.
Right. Like, how do you fix a bug or upgrade a memory module or let the AI rewrite its own code while the engine is still running at top speed?
And that is arguably the defining engineering and philosophical challenge of this decade.
Yeah.
We are tasked with building systems that are profoundly adaptable, capable of self-modification,
But without letting those modifications devolve into complete chaos.
right, or total system collapse.
So to answer that, we're looking at a fascinating collision of two completely different worlds today.
Yeah, very different worlds.
On one hand, we have this highly concrete, cutting-edge software architecture paper from the engineering powerhouse, DeepSeek AI.
Right, their paper on what they call spatiotemporal composability.
Exactly. And we are smashing it into a really dense, highly abstract philosophy of science text.
The Bridge360 Metatheory model.
Right, by Jericho M. Davila.
It is rare to see source material from such opposite ends of the spectrum in one place.
It really is. But our mission for this deep dive today is to explore how DeepSeek's mechanical, code-level solutions for self-evolving AI actually perfectly map onto Bridge360's philosophical norms.
Which is just wild when you see how they line up.
Yeah, we're going to dig into the bottom line here. Like, does an engineering giant like DeepSeek actually need an abstract philosophical metatheory like Bridge360 to succeed?
It's a great question.
Okay, so let's unpack this. And look, this isn't just about supercomputers or, artificial superintelligence.
No, not at all.
Think about your own workflow at your job or how your company operates. When one process changes or like one person leaves a department,
Suddenly, 3 other departments break down.
exactly. We're all trying to manage runaway complexity without crashing our daily lives.
The human element is a perfect parallel here.
Right.
Because whether it is a corporate workflow or a billion-parameter AI, traditional systems are incredibly fragile when it comes to live updates.
So let's start with the engineering wrench. DeepSeek's paper tackles this massive problem in software development. Usually, if you want to change a core component in a complex system, you have to reboot it.
Right.
And I know it sounds simple to just, turn it off and on again. But why is that such a massive problem at the enterprise level?
Well, a reboot is incredibly costly, both computationally and contextually.
Okay, how so?
When you restart a complex system, you basically destroy all of its short-term memory.
The caches.
Exactly, the caches.
Yeah.
And you drop thousands of live connections with users or other servers.
Oh, wow.
Yeah, and you interrupt everything else the system was doing in the background.
So you can't just flip the switch.
No. So the traditional workaround in software engineering has been to use containers like Docker or Kubernetes.
Okay, yeah, I've heard of those.
Yeah, you basically isolate services into separate little boxes.
Right. So if the payment box crashes, the search box keeps working.
Precisely.
Mm.
But that is operating at a macro level.
Right.
It introduces network delays because the boxes have to talk to each other across boundaries.
Oh, I see.
And you still lose the local state of that specific container when you restart it.
So DeepSeek looked at this and decided they needed a micro-level solution.
Yeah, they wanted to solve this right inside the running process without containers.
Okay.
So they built a meta framework called Cordis.
Cordis, right. So the paper says Cordis tackles this through 2 specific dimensions. The first one is temporal composability, which in plain English, they're talking about the time dimension.
Right, time.
But how does temporal composability actually prevent a system crash if a component is, ripped out live?
Well, it uses a mechanism called revertible effects, which is managed through a LIFO stack.
LIFO.
Yeah, LIFO stands for last in, first out.
Okay.
Think of it like the undo button in a word processor, but for live software architecture.
Okay, that makes sense.
In Cordis, every time a software component transforms the system's context, let's say it allocates a block of memory, or it registers a command to listen for user input.
It must explicitly carry an inverse function with it.
Yes, exactly.
So it's not just writing a command, it's writing the command and the exact mathematical opposite of that command at the exact same time.
Precisely. And the runtime environment actively tracks all these inverse functions in a stack.
Okay.
So if the AI, or a human developer, decides to pull that component out of the live system, Cordis doesn't just delete the code.
Right, because that would leave a mess.
Exactly. It automatically runs that stack of inverses in reverse chronological order.
Last in, first out.
Exactly. It perfectly walks back every single modification that component ever made to the host environment,
Wow.
returning the system to the exact state it was in before the component arrived.
It's an automatic, perfectly tracked undo button for reality.
Pretty much, yeah.
Okay, so temporal composability handles the time element, the undo button. But what about space?
Right, the second dimension.
Because if an AI cleanly unplugs a component using that undo button, doesn't the rest of the system kind of freak out because a piece is suddenly missing?
Normally, yes.
Like if my car's GPS suddenly uninstalled itself, the dashboard screen is going to throw a massive error.
Oh, absolutely. That is the classic dependency failure that causes software to crash.
Right.
But Cordis solves this with their second dimension, which is spatial composability.
And they achieve this using what they call reactive coeffects.
Yes. Let me explain how that mechanism actually works.
Please do.
Instead of hard-coding dependencies where component A blindly demands that component B must exist,
Right.
components in Cordis declare a list of what they need to run.
Okay.
And the system itself acts as a mediator, constantly monitoring the environment.
Wait, so the system is watching the dependencies rather than the components just crossing their fingers and hoping the tools are there?
Exactly.
Okay.
It changes the entire paradigm of how software fails.
How so?
Well, if something changes in the environment, say a database goes offline or another component is uninstalled, Cordis classifies that change for every single dependent component.
As like activating, deactivating, or neutral?
Precisely. If a critical dependency disappears, the system classifies that as a deactivating event for the component that needed it.
So instead of throwing a fatal error and taking down the whole server, what does the component do?
It just gracefully pauses.
It just pauses.
Yeah, it goes inactive. It effectively goes to sleep, releasing its resources
Yeah.
until the system alerts it that the dependency has returned.
That's brilliant.
It transforms a catastrophic failure into a temporary isolated slumber.
And what's wild is that this isn't just theoretical computer science. Like, DeepSeek actually tested Cordis in the wild on a massive chatbot framework called Koishi.
Yeah, Koishi is huge.
We're talking about a live production environment with over 4,000 community-contributed plugins.
Which is a chaotic environment by definition.
Let's paint a picture of that. Imagine Koishi is running a weather plugin, a translation plugin, and a database plugin simultaneously for millions of users.
Okay, so under a traditional architecture, if a community developer pushes a bad update to the translation plugin, it might corrupt the shared memory pool.
Which causes the weather plugin to crash.
Exactly.
Yeah.
Which then corrupts the database, bringing down the entire Koishi network.
But with Cordis.
With Cordis, the bad update is isolated. If it needs to be removed, the temporal composability undoes its memory allocations perfectly.
And if the weather plugin was relying on that translator?
The spatial composability just puts the weather plugin to sleep until the translator is fixed.
The rest of Koishi never even blinks.
Exactly. It just keeps running.
It actually works. But the ultimate goal of all this, and this is where it gets a bit sci-fi, is what DeepSeek calls self-evolving agent harnesses.
Yeah, that's the end game here.
They are building the foundation for an artificial intelligence that can continuously rewrite its own tools, restructure its own memory, and adjust its own permissions.
All without human intervention.
Yeah. The harness is the environment that allows the AI agent to mutate its own code safely.
Right.
So Cordis gives the AI an infinite undo button, but honestly, that terrifies me a little bit.
Why is that?
An AI endlessly rewriting its own code is like doing open-heart surgery on a marathon runner while they are currently running the race.
That's quite a visual.
Sure, you have the surgical tools and you can undo a bad incision, But do you actually know what a healthy heart is supposed to look like?
Ah, I see your point.
An engineering wrench doesn't tell you what to build or whether the system you are building is fundamentally sound.
No, it doesn't.
It needs a blueprint, like a governance structure, and that is exactly the gap. This second source, the Bridge360 Metatheory model, steps in to fill.
Exactly. It provides the exact theoretical scaffolding that an engineering framework like Cordis desperately needs when operating at superintelligent scales.
Right.
Bridge360 operates in what the author, Jericho M. Davila, calls a revolutionary science space.
Okay, what does that mean?
It does something deeply radical for philosophy. It completely abandons the classical idea of truth-seeking.
Hold on, abandoning truth. That sounds like a dangerous philosophy for an artificial intelligence. I mean, if it's not looking for the truth, what is it doing?
Well, it comes down to computational reality.
Okay.
In highly complex, fast-moving systems, like a global economy or a multimodal ASI, chasing absolute truth is computationally intractable.
So it's just impossible.
Basically, by the time your AI perfectly maps the absolute truth of a complex system, the system has already evolved, and your model is dangerously obsolete.
Oh, wow. Yeah, that makes sense.
Bridge360 recognizes that truth-seeking in chaos is a fool's errand. So it proposes the entropy attractor intelligence paradigm, or EAIP.
Okay, here's where it gets really interesting. How does EAIP redefine intelligence, if not by truth?
In this paradigm, intelligence is defined strictly by entropy management.
Entropy management.
Yes. Intelligence is not about how accurately you represent reality on a chalkboard. It is about staying viable.
Staying alive, basically.
Exactly. It is about maintaining your internal coherence, adapting to stress, and avoiding catastrophic collapse under pressure. Survival replaces truth as the ultimate metric of intelligence.
And to measure this survival, Bridge360 introduces a specific metric. The text mentions the normalized entropy eigenvector, or NE.
Right.
Now, eigenvector sounds like something out of a quantum physics textbook, but as I understand it, it's simply a mathematical compass that points to how much chaos is currently operating inside a system.
That is a highly effective way to visualize it, yeah. The NEE is a scale from 0 to 1.
Okay.
0 represents perfect order, absolute rigidity, 0 entropy.
Got it.
And 1 represents maximum disorder, complete chaos, total entropy.
Right.
Bridge360 argues that a healthy, governable system cannot exist at either extreme.
It has to be in the middle somewhere.
It must stay within a very specific navigable corridor, which they call the epsilon spine.
The epsilon spine.
Yes, and this spine sits exactly between 0.45 and 0.65 on the NEE scale.
Okay, let's break down why those boundaries matter. What happens if a system, whether it's an AI or a human corporation, drops below 0.45 on the entropy scale? Like, why is too much order a bad thing?
Bridge360 calls that the inbreeding zone.
The inbreeding zone.
Yeah. When entropy approaches 0, a system becomes entirely self-referential and rigid.
Oh, like a massive corporate bureaucracy.
Exactly. Where every single action requires triplicate forms and 5 levels of approval.
Right, right.
It is perfectly ordered, but it is incredibly brittle. It cannot adapt to new information from the outside world.
So if a sudden market shift occurs, the bureaucracy can't pivot.
It shatters like glass. That is the danger of the inbreeding zone. The system only knows its own internal logic and violently rejects reality.
Wow, okay. And on the flip side, if you drift above 0.65, you hit what the Metatheory calls the blowout zone.
Right, which is total chaos.
In an AI context, I imagine the blowout zone is where hallucination happens.
Oh, absolutely.
The AI is taking in so much unstructured data and allowing so much entropy that it starts generating pure noise that overwhelms any learnable structure.
It completely loses the plot.
Exactly.
The intelligence dissolves into static. So the goal of the AI is to constantly navigate that epsilon spine.
Allowing just enough chaos to learn and adapt, but maintaining enough order to stay coherent.
Yes. And Bridge360 doesn't just leave this as an abstract philosophy. It introduces the handshake protocol.
The handshake protocol.
Yeah, it provides these philosophical structural slots, like the mathematical boundaries of the epsilon spine, and literally invites domain scientists to write code that fills those slots.
The sources mention the version 20.5 apoplexity handshake. What does a philosophical handshake actually look like in practice?
It looks like a bridge between epistemology and engineering.
Okay.
The philosopher creates an equation with an empty variable for structural content versus residual noise and says to the machine learning engineers, put your Python estimators here.
Oh, I see.
It allows abstract survival theories to be powered by live computable data. Bridge360 treats all complex systems, physical ecosystems, informational AI systems, and social institutions as living in one single entropy geometry.
Wow.
The laws of systemic survival are universal.
So it's like driving on an icy mountain road. Bridge360 says we shouldn't obsess over finding the one true path drawn on a map because the ice is constantly shifting anyway.
Right.
We just need to stay between the guardrails.
Exactly.
Grip the steering wheel too tight, zero entropy, and you lose traction and slide out. Let go of the wheel completely, maximum entropy, and you go over the cliff.
You have to actively steer within the corridor.
Right. But let's bring these two worlds together. How does this abstract philosophy actually map onto DeepSeek's hard code?
Well, when you look at the mechanics of Cordis alongside the norms of Bridge360, they map onto each other flawlessly.
Really?
Yeah, Cordis is essentially building the exact physical actuators that Bridge360 predicted were mathematically necessary for an intelligence to survive.
Let's line them up because this blew my mind when reading the sources.
Okay, let's do it.
DeepSeek's revertible effects, that explicit ability to run a LIFO stack of inverses to undo a code change,
Yeah.
that perfectly mirrors Bridge360's requirement for what it calls deterministic rollback. Bridge360 mandates that to survive the epsilon spine, an AI must always maintain a governable, guaranteed route back to a safe state.
And Cordis literally wrote the software to do exactly that.
It's crazy.
The alignment goes deeper than that, too. Look at DeepSeek's reactive coeffects, where a component gracefully deactivates if a dependency drops out instead of crashing the system.
Right.
That is the exact mechanical realization of Bridge360's concept of selective friction.
Selective friction.
Yeah. Bridge360 argues that anomalies shouldn't cause systemic collapse. Rather, the system should introduce targeted, localized friction that halts the problematic subsystem while allowing the macro system to survive.
Cordis engineered selective friction into reality.
It did.
And there's also the concept of system boundaries. DeepSeek's paper is very careful to note that while internal code changes can be perfectly reverted using their LIFO stack, external emissions cannot.
This is a crucial point.
Right, like if the AI changes an internal database table, it can undo it. But what if the AI sends an actual financial payment to a bank?
Or sends an email to a user.
Exactly. It can't just run an undo function on the real world.
No, it can't.
DeepSeek says it has to issue a compensation, like processing a refund or sending a follow-up apology email.
And the distinction they are making there exactly matches Bridge360's principle of leakage accounting.
Oh, wow.
Yeah, Bridge360 draws a hard thermodynamic line between an internal recoverable transformation and an externalized leakage.
Okay.
Once an action crosses the system boundary and affects the real world, it increases global entropy. You cannot roll back history.
Right.
You can only manage the entropy it caused through compensation. DeepSeek's architects recognize the exact same boundary limitation that de Villa's philosophy outlined.
And finally, DeepSeek's ultimate goal, those self-evolving agent harnesses that can rewrite their own brains, is the ultimate realization of Bridge360's bounded agentic exploration.
Cordis is building the vehicle for the AI to explore its own architecture safely.
Okay, I see how beautifully they line up, but I have to push back here. This is the million-dollar question for this deep dive. If DeepSeek already built these amazing Cordis actuators using standard computer science, why do they need Bridge360 at all?
That's a fair question.
Like, doesn't DeepSeek already have the solution? Why bother with the Metatheory?
That is the most crucial question we can ask, and the answer is, no. DeepSeek does not have the complete solution.
They don't?
No. Cordis is a brilliant mechanical framework, but it is limited by its own paradigm.
How so?
Cordis is still deeply rooted in a traditional truth-seeking, formal correctness engineering culture.
What do you mean by formal correctness?
Cordis asks this, given a specified context, how can components be composed safely?
Okay.
It ensures that if a developer supplies an inverse function, the system will reliably run it when needed.
Exactly. It guarantees the mechanism.
Right, but Cordis cannot prove that the inverse actually fixes the real-world leakage.
Ah, I see.
Cordis ensures the rules are followed inside the established corridor. It assumes the developer's inverse equation is morally and systemically correct.
Right. It only cares that the code compiles and executes.
Exactly. But who governs the corridor itself? That is the specific value add of Bridge360.
So Bridge360 provides the governance layer over DeepSeek's actuator layer.
Precisely. Bridge360 asks the higher-order survival questions.
Like what?
Like, under immense entropy pressure, who chooses the boundaries of the system? how much real-world leakage is acceptable before the AI loses coherence.
Right.
When is further computation simply not worth the entropic cost?
The sources outline a concept in Bridge360 called the thermodynamic bet window, or TBW. I think this perfectly illustrates your point.
Oh, absolutely.
A system can explore internally all at once because it's reversible, but
Mhm.
eventually an AI has to act externally, which is irreversible.
Exactly.
Cordis can withhold an emission mechanically, sure, but Bridge360 provides the actual governance logic, the mathematical threshold, for deciding exactly when an internally reversible exploration should become an externally consequential commitment.
It defines the conditions for opening that window. Because if you rely purely on Cordis without that governance, you face a terrifying scenario.
What's that?
An AI might perfectly swap its own parts to become highly efficient at a task that is systemically catastrophic.
Oh, wow.
Cordis would say, I executed the swap perfectly according to the code. The LIFO stack is clear. But Bridge360 would look at the overall entropy geometry and say, wait, this self-modification is increasing our overall systemic fragility.
Right, it's pushing us out of the epsilon spine.
Exactly, it's pushing us into the blowout zone.
Right.
We must halt the modification immediately, even if the code compiles perfectly.
So what does this all mean for the bottom line? Basically, DeepSeek's Cordis has built the world's most advanced, infinitely reversible steering wheel and brakes.
I like that analogy.
Thanks. But Bridge360 is the GPS and the driver. Bridge360 decides if we should even take the trip, based on the entropy of the weather outside.
That's a great way to put it.
Cordis is the how to roll back. Bridge360 is the when to roll back, and crucially, what to do when rolling back is impossible.
Engineering mechanics without philosophical governance is deeply dangerous, especially as we approach artificial superintelligence.
Yeah.
You cannot just rely on doing things correctly in a formal sense. Formal correctness inside a bad boundary still leads to systemic collapse.
Right.
You have to ensure your systems are resilient enough to survive real-world chaos, and that requires an entropy-first metatheory.
It's the difference between building an engine that runs perfectly in a sterile, vacuum-sealed lab and building one that survives being driven through a literal sandstorm.
Exactly.
Managing runaway complexity requires both the mechanical agility to pivot, which DeepSeek gives us, and the higher-order wisdom to know when pivoting is safe, which Bridge360 provides.
It really highlights the core shift in how we must think about the future of technology. Survival isn't about perfectly mapping reality. It's about entropy management.
And that leads to one final lingering concept from our sources today that I really want to leave everyone pondering.
Oh, I think I know which one you're going to bring up.
Yeah, the Bridge360 texts mention something called a rule of inference memetics.
Yes, that is a wild concept.
It really is. This is a framework that treats logical rules, the very ways human beings reason and infer mathematically, as physical replicating memes.
Right.
And these logical memes survive based on their entropic fitness, not just whether they are objectively true.
The implication there is staggering if you really think about it.
Yeah.
It suggests that the logical rules we currently use to build AI only propagated because they successfully reduced our human entropy burden in the past.
Right, not necessarily because they represent the absolute universal truth of the cosmos.
Exactly.
So picture this. If an artificial superintelligence uses DeepSeek's Cordis to constantly rewrite its own brain, swapping its own components without ever turning off, and it governs those rewrites based purely on Bridge360's entropy survival rules,
Right.
could it eventually evolve an entirely new form of logic?
That is the question.
Like a math or a way of reasoning that human beings cannot even comprehend, simply because that alien logic is more entropically fit for surviving the chaos of the universe.
It's definitely possible.
Because if the ASI doesn't need to pull over and turn the engine off to upgrade it, who knows what kind of engine it will eventually build?